This is our first task. Can you see our first task?
Yes, I can see it now.
Okay.
R1 should be configured to use unicast to establish EIG neighbor agency without. R1 should use multicast to establish an EIG neighbor adjacency with R3. R1 also R3 to use an EIGRP named mode configuration to accomplish this task.
Okay. So that is our first task. I actually started the task, but let me clear it and then let's start, okay? So what was the first thing we're supposed to do?
Establish unicast. Everyone should configure to use unicast to establish an EIGRP enable adjacency with R2. Hi Lancelot, I have one request, please. Can we record the class? So we
It's
can
actually
have
being
it.
recorded.
Okay,
It's
great.
actually
So
being recorded.
we can
Actually,
review it. Okay, thank you.
yes, it's actually being recorded. So I had started with the configuration. So let me end this. Okay. So anytime we have a question to look at, right? Will I bring up the topology again so that we actually have an understanding of what we're doing?
Yes, please. Sorry about that. Yes, so we can look at now that we know that we are doing R1 and R2 unicast adjacency. So we can take a look at the topology once again.
Okay, so let me see if I can stop this share. What did I do to myself? I didn't bring my second screen. Let me see if I can share the screen. Okay. Okay. Are we there yet?
Okay. We can see the topology. So behind. Okay, now it's very fine. So R1, R2. Okay. We are unicast. So they have a direct path to each other.
Yep. Okay, so now on the regular, EIGRP, when EIGRP connects to another box, EIGRP connects or sends multicast on the popular IP address of what now? 224.1.1.10. Regularly, that's how EIGRP connects, or that's how EIGRP speakers talk to each other. They use the well-known multicast of 224.0.0.10. But then back then, there used to be a challenge. You could actually have some slow links, or you had something like a serial link or a service provider that was actually stopping you from running multicast or dropping multicast traffic, right? That's one. Another reason could be you don't want to use multicast across those ones because it's not important, since it's actually like a point-to-point link. So in this case now, we are supposed to establish a multicast between routers 1 and routers 2.
So routers 1 and routers 2 is unicast. Routers,
Yes.
I think, yeah.
Okay. Now, if you look at underneath the topology, if you look at the diagram, the multicast unicast configurations for routers 1 and routers 2 are on the interface for router 1, J0/2, which is in the S200, and for router 2 is G0/1. So let's look at this and let's start. The other thing it says is routers 1, routers 2, and routers 3 should use EIGRP in a named mode. I'd actually started playing. So let's look at this. And then let's do a short interface brief. This is my most popular command. Most times I do the show IP interface brief command. I pipe it to exclude unassigned IP addresses so that I'm only clear on what I have. So on router 3, we actually have the G0/0/1 interface and the G0/2 interface. Am I audible?
Yes, you are. Yes, you are.
Okay. So let me just item 2 so that we can actually look at. I will copy and post this later on the chart. So let's look at this. So now that we are supposed to do one of two things, use multicast to enable. Now, there are two lines there. They are saying one, use multicast. The other thing the line is saying is used name mode. Did everybody see that part? Hello? Did everybody
On
see
the
that
question,
part
yes.
underneath? Yes.
On the name mode,
Okay.
yes. That's the last part, yes.
Beautiful. Thank you. So no matter how the questions come or things get across, you might have to do one before the other. There is actually no format to do it, but you actually will need to do that to bring it up, okay? So if we go to our devices now, so let's go to router 1, right? Let's do a show IP interface brief, pipe to exclude unassigned. Control A, go back to the beginning, put the do sign. So we can see we have the bit 1, 0/0, 1/2, 0/3, and all of that. Most times when we build topologies like this, if you notice, the 0/2 has a 12 IP address, right?
Sorry. For this is we are on R1 and we are connecting yes from G0/2 yes to R2.
Okay, let's confirm that. Let's go to R2 and do a show IP interface brief, pipe it to exclude unassigned. What do we have on that interface as well?
Yes, 12.1.1.2.
Beautiful. So if I do a ping to 12.1.1.1, I should be able to reach router 1.
1, yes.
Okay. So that means that is the interface that connects them. Yes. But then it says we should use name mode. That's the first thing. It also says that we missed that part where it is supposed to be, they are all in the address family of, they are all in, okay, they are all in EIGRP 100, yes?
Yes.
Okay. So what name should we use? Since Abdul Malik hasn't spoken today. Should we use Malik as the first name mode? So
Abdul Malik has
EIGRP
been the
could
one
be,
speaking.
he has not been speaking. Him and Salem have not been speaking. I'm putting
He's
your
Abdul
next.
Malik that has been speaking. He's Abdul Malik that's currently speaking.
So EIGRP could be in two ways. You could use classic EIGRP, or you could use named EIGRP. The problem with classic EIGRP was, if we're going to do classic EIGRP, we are going to be specifying every address space different, every autonomous system different, every VRF different. Let me give you an example. So let's say I do router EIGRP 55. This is the name mode. In classical mode, you have to now go and start doing everything. So, and start setting network statements. So let me exit this and say no router EIGRP 55. So that's how classic works. So in name mode, I actually have to give it a name. Now I can specify an address family under named mode. For IPv4, IPv6, they are all in the same space. Unlike in the old classic mode, they actually have to be in different spaces. So we said we are doing router Malik, right? EIGRP. And we are going to, and you see, it will tell you the autonomous system number, which is the range of 1 to 65535 or a word. So we are going to say Malik, right? Boom, boom, boom. So when router EIGRP Malik, now if you use the context sensitive help, it will first ask you, do you want to do a service? Do you want to shut it down? Do you want to exit? Do you want to do something? So if I specify that I want to use an address family, remember, right now we are talking about IPv4 because this IP address is IPv4, right?
Yes.
So that means I can actually do IPv4 and IPv6 in that same space without going away. Yes?
Yes.
So I want to do an address family of IPv4, right? IPv4, right? Now I can say make it a unicast as a family. And then this command actually comes helpful when you are doing BGP, because when you are doing BGP, it's always unicast. I can specify a VRF as that, or I can specify an autonomous system number. From our stuff, we know that most of these people are in the autonomous system of 100. So AS will be 100, right? So I can put the AS shortcut or autonomous system and I go 100, right?
Right.
So can you see I've now left the router space? I've now entered that IPv4 street address space. I could have done that on IPv6 and now I've done the same thing. So let's do a show IP interface brief. Let's pipe it to exclude unassigned so that it's easier for us now IP addresses. Now, at the last class, I said something. I said, other than BGP, on most IGPs, when you use that command network, you are not telling it to advertise a network. No, you're actually telling it what interfaces actually participate in that network. So most times, especially in production networks, when we configure classroom or classless routing protocols, we actually make mistakes with the network mask. So for me, I rather advertise each interface as one. And then if you look at it, we have all these interfaces in EIGRP 100. So instead of punishing myself, I'll just go the network there, which will be this interface I want to participate. Give it just it. That's the only person I want to participate there. That's all. The next interface I say in that is this. So I will place this interface. I have the 12 network, I have the 13 network. Whoops. I have the 12 network. I have the 13 network, right? I have the 13 network. I have the 145 network. Then I have all these loopbacks.
Mommy.
So there are some interesting things we can do with OS EIGRP. EIGRP has a couple of tables, which one of them is the neighboring table, the interface table, and the topology table. So let's do a show IP EIGRP interfaces. Brief, let me hope this iOS picks it up. So you can see all the interfaces that EIGRP is running on. But then we actually said we do not want a particular neighbor to actually use multicast. We want the neighbor to use unicast. For you to be able to do that, even in other routing protocols like EIGR, like OSPF, the only thing you need to do is statically define that neighbor, who the neighbor is in that address family space, and then the interface. So the command will be neighbor, and our neighbor is 12.1.1.2, and is on gigabit 0/2. Am I correct?
Yes, that's
Yes.
correct. It's on 0/2, yes.
And it's on gig 0/2, so that it knows that on that interface, just talk to it directly, right?
Yes.
So I think that's one part of it. The other part now, it says that router 1 okay, so let's do that. That's for that, right? But then we have another interface, if you recall, on that router that is on AS200, which is G gig 0/9. Am I correct? Or am I missing this? Yes. So, and that is in our autonomous system. So I'll have to exit from this router's interface. And then let's create for 200, let's do router EIGRP. Let's name it after Salem. But then because we are doing the EIGRP 200 here, let's name it 200 so that we would know. So as usual, address family V4 unicast AS200, network being 10.1.1.1. Then do it right. So let's go to router 2 and see what we can do. Did I get an error? Oh, right.
The configuration did not save.
Yeah, it's saved now. Thank you. So let me show an IP protocol to be sure we have nothing running here yet. So we have nothing running here yet. So for EIGRP 100, we actually used Mavic, yes? So let's do the
Yes,
same
that's correct.
here. Router EIGRP Mavic. Let's make it 100 now so that we are sure of the AS we are running on, right? Family IPv4, unicast, AS 100. So let me show IP interface brief, 5 to exclude unassigned. So our network will be 12.1.1.2. Network 23.1.1.2. Network, this is the loopback 2.2.2.2. Then if you remember, we actually said the neighbor, which is on the gigabit interface, you use unicast, right?
Yes.
So we need to specify that the neighbor, which is 12.1.1.1, is on gigabit what now? 0/1?
Yes.
Okay, moment of truth. If we have configured this properly, we should have the router complaining. Did the router complain?
No, it's up.
Yeah, it just says it's up. Beautiful. So we also said that we have the other autonomous system 200, right? That we named after Salem, if I remember. Yeah?
Yes, Salem 200.
Okay. Yep. Same address family. And do you know why I'm naming it 200? So that it makes it easier for us to remember the AS number we put on it, right? And that address family is IPv4. Autonomous system is 200. And then it's advertising its interface, which is 10.1.1.2. So you can see that that adjacency is up. So if we do a show IP EIGRP neighbors, you can see that on gig 0/1, we have a neighbor relationship. Can you see this is under Salem? Can anybody say this? This is
Yes,
Malik.
I can. Yes, Malik
On AS 100. Okay, and then Salem on that. So do show IP route, EIGRP. So we can see all these loopbacks that are coming from route 1, yes? And then the 13 network, which is between routers 1 and router 3. So can anybody still see the chat box?
Yes, the chat box is still visible. I'll be coffee.
So remember that we also said we should use multicast, right, to establish EIGRP neighbor adjacency with router 3, yes? Is that not part of it?
Yes, that was part of it, yes.
Okay, so we need to go to router 3. Now, what are we going to name this address family now? So router EIGRP Malik 100. Address family IPv4. Autonomous system 100. Yes.
Yes.
right?
Yes, so this will be multicast.
Thank
Okay.
you. So as usual, I always do a show IP interface brief, pipe to exclude unassigned, so that I do not make mistakes, right? So let's look at the networks we have. We have a network of 13.1.1.3, and as usual, we only send that interface, right? Before
Yes.
we do, oh, the moment we brought it up, you notice that it has brought up its adjacency with router 1, because that they are on the same interface, yes? So we now have network 23.1.1.3. As usual, we send only that IP address. Router 2 should come up. And then the next one is loopback interface, which is 3.3.3. And then we are sending that up. So now that we think we are done, let's see if we can verify what we did. Oh, all the adjacencies are coming up. Let's do an end here. Let us write it. So I do. Okay. So let's do a verification, right? Show IP route EIGRP 100 pipe, and then let's begin with get. So while at this, please take note of these two lines. Administrative distance. Is this big enough? I should increase the size. Is font size better now?
The font size is fine.
Okay. So if you look at it, please take note of what I highlighted. You can see two figures there. You can see administrative distance, and then you can see the metrics. Now, can somebody please look at this third line and tell me what this third line means, or what you can make out of this third line?
Yeah, I think the third line shows that to reach this subnet 23.1.1.0 via 13.1.3 and has a longer time to reach their subnets rather than the other subnets up. I don't know if I'm correct.
Okay, no. So it's telling you that it has a network. We are correct, but not very correct. It's telling you that this network, 23 network, right, is discovered by D, and this ESPS. And it's
Yes.
telling you that because it can go through this gateway, which is G03, or this other gateway, which is G0/2. Remember that this 23 network is between routers 2 and routers 3. So since because router 1 has a connection on its interface to router 3 and then to router 2, and that network is behind them, it can see them, and then there are two routes to that network. Okay? Let's go to, let me see if I can stop sharing. And then let me share. Hello, who did I miss? There are a couple of new people on the blog that I did not see. So, can you see my screen now? Hello,
Yes.
proof of
Yes.
Yes, I can
Okay.
see your screen.
So that dot 23 we are referring to is actually between routers 2 and 3. That's the dot 23 network, right? The dot 23 network is between routers 3 and 2. So router 1 here is saying, I can get to it through my G0/2 or through my G0/3 because this is the network and then they are doing the same thing. But because these networks, let me explain, they actually basically are all gigabit Ethernet. We haven't changed anything on them. So they actually have equal distances to go with them. That's why it's putting both of them in there. But let me see if I can do this. Let me see if I can tweak this. I was trying to see if I can add a jitter or something on this link. Okay, quality. So what should I put on the link? Should I put a delay or a jitter? Or I should create a loss? The things that EIGRP uses to calculate. If I create any of these right now, you will notice that that route that was showing you at equidistance will not be equidistant, but we'll come back to that. We'll come back to that, okay? Let's go back to, so let's take a breather. Any questions? Any questions?
None from my hand.
Okay, I'm trying to, what is wrong with my screen? That's not trying to share. Oh, okay. I need to stop this share and share items again. Okay. So let's go back to router 2 and then do a show IP route, EIGRP, right? 5, and then again with the gateway. So you can notice that the gateway for all the loopbacks on router 1 is going through gig0/1. Now, if you look at the .13 network, the .13 network is the network between routers 1 and router 3. And you can see the 13 network through gig0/3, which is its local interface, because it's close, I think. So I think our first task is almost up and done. So any questions? Hello, any questions?
I have just one question. So,
Okay.
when you are establishing connection between those interfaces, when you are specifying the EIGRP name, once you don't specify unicast, right, it's going to automatically use multicast traffic. Is that correct?
No. So IPv4 unicast is an address space that regular IPv4 talks, like
Okay.
IPv4 VPN and all of that. So they are different. So our regular routing is on IPv4 unicast address spaces. Yes.
Yeah.
So even if you don't do that, the basic thing EIGRP does is EIGRP uses multicast to the well-established number 22.0.0. But sometimes you do not want EIGRP to do multicast or send multicast traffic. So you now specify a neighbor in the EIGRP process and tell it this is the interface to which that neighbor has. So the neighbor is actually statically stated. You can do the same thing with OSPF as well. And then some other of those IGPs can do that, where you want to disable the multicast function of those routing protocols and then just allow direct unicast. Now, there are some networks. We might be connecting from your router at a branch to HQ and vice versa. And then because your service provider decides to throttle multicast or do storm control, you might actually have issues forming that relationship or that pairing because multicast is disabled. So it's a lot of overhead. I particularly, for some reason, now, and I'll tell you why I like to pair with names on the interfaces and then unicast. That means if there's any other router listening on that segment, right? Because it's only sending that traffic to this particular neighbor. Every other EIGRP router on that segment will not hear it because it's actually sending it is a unicast to one particular router not like as a regular where you actually send multicast to every router that is running EIGRP. Clear enough?
Yes, clear. Thank you.
Oh, okay. Hello, Blessing. Are you getting confused? Welcome to our house.
Good morning. Thank you very much.
So you came in a little bit late. I don't think you missed too much. But yeah, here we are. So on the chat board, we have our new task. Can anybody see our new task on the task box? On the chat box, I just placed our new task. And everybody say it.
Yeah, I can see it.
Yes, you can see the new tax. Yes.
Okay. Now the new task says we should configure routers 4 and 5 in EIGRP named mode. Yes, CTO, you raised your hand. Please speak up, sir. Is it about my shoes?
No, sir, I came late, sir. I just wanted to. I came late, sir. Sorry, sir.
I thought you were going to offer me my shoes. You know, I'm a nice guy.
Last time.
Okay, welcome. So we're talking basically EIGRP, and then we are doing a couple of tasks. On the chat box, the chats are there, the task 1, which we have just done. We're talking, while you came in, we're talking about why sometimes you might actually need to just use unicast between your EIGRP pairs. Since
can I add something here?
Yes, please.
In a very funny way, yeah.
Yeah.
You know how you take a girl on a dinner and you never ask her to be your girlfriend?
Yeah, you assume.
You assume. So don't allow your routing protocols assume that you want to use unique multicast. Statically tell them that, look, guy, I want you to be unicast too. Don't go and misbehave.
Thank you.
So I have very funny ways of. Sorry, guys. I have very funny ways of explaining things, so that when you just remember it, you say, CTO said it like this. So yes, so you take a girl on a dinner, or you take a babe on a dinner, and you didn't ask her that. Oh, this what's in my mind, though. You know, would you want to be my girlfriend? I would like you to be my girlfriend. You know, and you didn't tell her. You are just assuming that you are dating. And one day the babe just tells you, but you didn't tell me. Another guy told me, which means she has established neighbor with the person that said it out. Right? I mean, so just add it to whatever my idolo has said, you know.
Ha ha ha. I'm looking for my shoes. So that's basically that. Our topology is here. So we are supposed to, on our new task, we are supposed to create neighborship between routers 4 and routers 5. And we are supposed to use name mode. So as usual, our interfaces are set. So on router 4, we just have the 145 subnet that is actually connecting routers 1, 4, and 5, and they are in the EIGRP autonomous system of 100. So since CTO is around, no blessing came first. Let us name this instance after CTO. So name mode, router, EIGRP, CTO. But let's put that 100 so that I can remember that we are going to EIGRP 100. As usual, our address family is IPv4, unicast, autonomous system of 100. We already have our networks actually displayed for us, the interfaces that want to participate displayed for us. So that will be 145, so 1.1.4. And the next one will be the loopback, which will be 4.4.4.4. You notice the moment we finished entering that command, EIGRP is that fast. You notice the adjacency came up immediately with router 1 on that 145 subnet or 145 network, as it were. So if you do a show IP route for EIGRP right now, it will actually have pulled routes from router 1. So right now, router 4 actually knows how to get to the loopbacks of router 1. It knows how to get to the loopback of router 2, but through router 1, you can see the gateway is router 1. It can get to router 3, the gateway is router 1. It can get to the subnet between routers 1 and 2, all through router 1, because right now it has only one pairing relationship, and the only person it's pairing with is router 1. So all the network is finding is actually going through there. So let's do the same for router 5. So since blessing just came, let's name it after blessing, and let's put that 100 keyword there. Let's remember it's in the address family of IPv4. As I said earlier, you can do IPv6 in the same space. The autonomous system is still 100. Let's do an IP interface bridge so that we know what we actually send in. So let me send in the loopback of the first loopback and then the gigabit interface into that. So the network will be 145. Sorry, the participating interface. Why do I network? Now I have a problem. How come EIGRP neighbors on router 5? Anybody help me? Or did I misconfigure something? I can see my adjacency up, but I am wondering what I did wrong. Five. Okay. Hello, William. Good morning. So why am I not saying let's say a little troubleshooting? Let me ask myself why my adjacency is not up. And that brings us to, okay. So yeah, I have an address family, IPv4. And then I am not bringing that up. Okay. Can anybody think up of something that will actually make this not work? Okay. Okay. Forgive me. Looks like I need to turn on my glasses. So I cannot find my neighbor relationship. I cannot see that interface participating in EIGRP, which is not a challenge. So let's knock off the EIGRP first. Let's start again. Router EIGRP. Lesson read. Address family IPv4. Unicast. Normal system in red. Network 505.5.5. Network 145.1.1.45. That oh boy, people of God forgive me. I was the foolish one, putting the wrong IP address. Sorry, it happens sometimes. So, are we still on this call? Or I've lost myself.
Yeah, we
are
can hear
still,
you.
yeah.
We can hear you.
I was the same person that I always say I do my do show IP interface brief all the time, and then I am putting in a wrong IP address. And my bad. So we have all the EIGRP routes coming up, and then I think we should be fine for that. But then part of that tag says that routers 1, 4, and 5 should actually use they should use unicast to actually establish their adjacency. Am I correct? And so remember how we did use the unicast?
Like the IP address family,
Yep. And then the neighbor and the neighbor name.
by neighbor name, yes.
Okay.
And the
So
unicast.
remember we are using named mode, and then router 1 connects to both routers 4 and router 5. If you do a show IP interface brief, you actually see it connects on the 145 sub. That's why we can do a ping to 145. So 1.1.4, that'll be router 4, and then .5, that'll be router 5. That in that sub network. Okay, but let's do a show run. Let us pipe to the section of EIGRP. Let us see what we configure the EIGRP 100 under, so that we do not make a typo and we have an issue with that. Okay. So EIGRP 100 is Malik. Copy that. Config T. Malik. On the address family of still IPv4, because on autonomous system 100 as usual. So I have a neighbor that is 145.1.1.4 on gig 0/0. Neighbor. And then I have, you can see that it went down, and can you see it says EIGRP down? Can somebody read this line of what it says? EIGRP neighbor down.
Static pair replaces multicast.
Cast. Beautiful. Now we need to do that on the for 5. So it's just said the same thing. Static down and that. But let's go to router 4. Are we still in that address? You can see the interface went down. So since we are doing unicast for both sides, you have to do this one first, then the other one later, because you want to do it on both sides. Will it work if you have multicast and unicast on one side? It would work, but it's actually just good practice to just make sure that they're actually the same on both sides. So this is the EIGRP context here. Address family before red. Now, because we replace this, if we do a show IP EIGRP neighbors here, You notice that route 4 and 5 have been knocked out because one side is doing multicast, the other side is doing unicast. So let's say we can go and fix it. That is one. Let's see if we can go and fix it. We can see that we actually did a termination when that happened. So because of the more access segment, since you have decided to actually not specify the neighbor, you actually have issues. But remember, there is multi-access. So in that multi-access network, you have routers 4, 1, 4, and 5. So if since one has already said I'm doing multicast with 4 and 5, 4 2 should come and say I'm doing multicast with 1 and 5, and vice versa. So we have to statically now specify the neighbor 145.1.1.1. And it's going out through the gig 0/0 interface. This should bring it back up now. So the adjacency should be up. You do the same thing with 5, because on the side of 5 is still configured as multicast, so it will not work. So I think we are still in the same address family. So the only thing we need to do is just specify the neighbor 145.1.1.1 on the G0/0 interface. And 1.1/4. They should bring their backup. So if we go back to router 1 and we go do show IP EIGRP neighbors, you'll notice that the neighbor relationship that wasn't there before, these two relationships are backup. So, any questions?
No questions. So just to clarify once again. So once you are doing unicast for EIGRP, you have to ensure that it's configured on both sides. If not, you won't be able to. The adjacency will always remain down if you just configure just on one side.
Yeah, it will use remain down or stock inactive. Yes, because
Yeah,
one guy is speaking Greek, the other guy is speaking Latin. So because you've decided to statically configure it, it is looking for its neighbor for that particular neighbor at that IP address. And that one is sending a multicast to everybody. So since we've actually statically told it, just listen to these two people talking to you, it closes its ears to every other thing coming in from somewhere. So you definitely will not be able to establish an adjacency. So can we go to, how long have we been in this class? An hour already? Hello, everybody. My name is Lance. What did I miss? Where's everybody? Let me see.
We're with you. We're with you.
Okay.
Sir.
Look at the chat again, and then we need to do, what is our next task now? Configure router 6 in EIGRP AS200. It should run it on its loopback. I should use name mode. This is not getting boring. Named mode. So sorry, I did not place this topology here. So let me stop sharing, and then let me reshare again, so that you can everybody can have a view of what the topology looks like. So the topology looks like. Can I take a breather for a minute or so? Let's familiarize ourselves with the topology. I shouldn't pause sharing, should I? Hello?
Yeah, hello, sir.
You're sharing already. You're sharing already, Lance.
I've seen it already.
I'm trying to see if I should just take a while for everybody to just familiarize themselves with the topology or something. So that when we are speaking to, hey, we are moving this to here, everybody actually understands. Okay. Can anybody now relate this to, is everybody comfortable with the diagram now? Can I take it off and let's go back to our configurations?
Yes,
Yeah.
yes, I am.
Yeah, you can continue.
I see you. Danny, I see you. Hello, everybody.
Hello, Lance.
Okay. Hello.
Yep.
Okay. So let us go back and share item 2. Okay. So this is on router 1. The routers we configured was router 5. So let's do a show IP route. And then there is something that OS EIGRP does. And we might come to that problem later. EIGRP does what you call a split horizon. And because of that split horizon, what it receives on one interface, it might not give out on the other interface. But not to worry. Our next class says we should configure router 6. In EIGRP AS200. So we are going to do the same named mode of EIGRP. So this is router 6, configure T, router EIGRP. What are we naming this one after? Well, this after Mubarak. You came in late to my class. Okay, Mubarak. Let's name this after Mubarak. And in AS200. Address family as usual is IPv4, autonomous system 200. If we do a show IP interface brief, exclude unassigned, we just have the gigabit interface at that. So network, you're going to do the 6.6.6.6. The other network will be 10.1.1.6. Okay, so the adjacency is up. So let's go to router 1 and config. Oh, it has seen it. So do show IP route EIGRP 200. Begin with the gateway. I just realized that this thing is crazy sometimes if I use a capital G. So you can see that that gateway for EIGRP 200 has that route there. So I think we are done with our tasks 1, 2, 4. Anything else? Anybody want to ask another question? Let's play before we go to 5, 6, 7, and 8. Any questions, please? Hello, am I still on this call?
Yeah, you are. Yeah, you are.
I am trying to send a chat. For some reason, I cannot send the chat. Okay. Okay, I think I'm good now. So please check on the chat box. And let's go to the interesting parts for 6, 7, and 8. Okay, am I the only person here? Hello?
I'm with you. I'm with you.
Oh,
Well,
okay,
with you,
okay.
sir.
Okay, there's no sir. My name is just Lance. So, tax 5 says we should configure OSPF area 0, which is the backbone area, on router 6G0/9 and router 7G0/9 and loopback 0 interfaces. The router ID of those routers must be configured as 0.0.0.x, where x is the router's number. So that means router 6 will be 0.0.0.6, router 7 will be 0.0.0.7. So let's launch routers 6 and 7 and let's see how it goes.
Dear customer.
7 is been, yes, go on. Who knows how to do the alias command? Hello, who knows how to do the alias command on Cisco iOS?
Do you have 2 numbers now?
This one is my 5 number now. I remove it and put in this phone.
Okay, I don't have this one now.
Yeah, this one is that one I use and
Hi,
share.
Percy, can you
This
mute?
thing.
Hi, Percy, can you mute? Thank you.
Okay, sorry, I was asking the class. Has anybody used the alias command before on Cisco iOS, please?
Not sure, sir.
Not sure of that.
Okay, so let's do a trick. If you notice, always I go show IP interface brief and I pipe it to exclude unassigned, yes?
Yes.
So that's the command I constantly use, show IP interface brief, right? I keep typing it. So why don't I create an alias that it can be a 3-letter word that just does that for me? And I'm trying to see, what's that command again? So there's an alias, what am I doing? There's an alias command you can do on Cisco iOS, right? Okay. So the alias command just says that, use this command, this shortcut, instead of having to type it all in full. Okay?
Okay.
Okay. So it's just a trick that you just use for numbers you repeat constantly, right? So that's about that. So alias And in the exec mode, I want to do an alias for an exec level command. Yes? Okay?
Okay.
Right? So what's the word? Show IP interface brief. Whoop. Sorry. Alias an exec command show IP interface brief.
brief.
And what's the line?
Show IP interface brief.
Then the line.
Show IP interface brief.
Then the line is show IP interface brief. Okay. So look at now, do is the same thing. Get it?
Yes.
Yes. Just like the
Yeah.
same, just like doing alias on a Linux box also.
Thank you. Thank you. So you can do an alias on it. So 5 says we should configure OSPF on routers 6 and 7 interface and loop back and router ID. Okay? So for router 6, has any of you done OSPF from interface before?
No.
Yes, I have. In a small lab.
The router ID, just because of this router ID, I will just do this, right? 0.0.6. Is that not what he said? That should do XXX, right? So I'm going to exit from
And the
here.
router's
And he
name.
said, yes. What?
Like 0.0.0 the router's number.
Yes. Which I have done, right? But then he says on the G0/9, right? So I'll just go to interface G0/9, right? IP OSPF. What OSPF area was it?
0.
Process number OSPF 1,
Area 0.
area
0.
And I'm supposed to do that on the loopback as well, right?
Yes.
So to show IP interface brief, interface loopback 0, IP OSPF 1, area 0, to show IP OSPF interfaces. So you can either use the network command or you can use the interface sublevel command. So let's go to router 7. Router OSPF 1, router ID, yes, 0.0.0.7. So we are doing it on the loopback of, are we doing on the loopback of 7 as well? Yes. So interface G0/9. Okay. Now, these machines are not, they are connected on that interface. Let's see what routing protocol is running in router 6. So we are running EIGRP 200, we are running OSPF 1. So let me show IP route. Okay. So we are done with that part, yes? Hello?
Hello.
Yes. So on 6, it says redistribute OSPF into EIGRP. Such that R1 and R2 go directly to R7 to reach the 7.0.0 network. Whoa, that's a long one. Has anybody seen anything like this in production, in real life, or in the lab?
I did this in a lab. I've not done this in production.
Okay, so remember, if you are doing, it's all relating to how some protocols work, like EIGRP and AGP. They could be very, 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 very anyhow. They do not change the next up. They want to put next up itself. So they actually will be making you, don't worry, when we go through this, you understand why. So let's do the mutual redistribution first, yes? So do show run pipe to section, EIGRP. So unlike classic EIGRP, because you are doing named EIGRP, you actually need to go under that process in EIGRP to be able to actually do redistribution. And we did it under Mubarak. So let's do this. Let's specify the address family IPv4, autonomous system 200. So you cannot just come up over here and do it. Under that topology right now, you now have to, that is where you actually get to work on it, right? So you don't have the redistribute command here. So you need to go under the topology base. Sorry, to show version. So under the topology base, we would now have to, if you look at the topology base, under it, that's where you can do things like default information, originate, change distance, create redistribute list, specify things like metric pass or offset list, because unlike classic EIGRP, where it's all under one space, say you actually go to these subdomains to be able to do that. Are we good? Well, I've got to somebody lost. So let me read it. EIGRP. Let me read this to OSPF 1. And then I have to give it a metric so that it will think, it will be able to advertise it properly into EIGRP. So I'll give it a bandwidth. It will still ask me to give it a delay. She asked me to give it reliability. It will see, ask me for effective bandwidth and then MTU. So I've done the advertisement into EIGRP for OSPF. But let's be sure we can say it from router 1. Let me do a Are we here?
Yes.
Okay. Is this part a little bit confusing? The redistribution part.
Yeah, it is a little.
Okay. Okay. I might have to take time out and do redistribution. Okay. So redistribution basically is like translation. Okay. PGP does not speak OSPF. OSPF does not speak it, but inside of the protocol, they can actually, you can bring a protocol into another one so that you can let it go. So this happens when maybe you have, like in this case, we have a router that is speaking EIGRP somewhere, and then between router 6 and router 7, we have OSPF, and we want that network to get to the EIGRP network in router. Remember that router 7 is not running EIGRP, it's running OSPF. But that network, it advertised it to router 6 via OSPF, and router 6 is in the EIGRP domain. So it can now redistribute that route to itself so that by the time you want to come to it, you know that you are coming off of it, off of router 6, and router 6 now sends it back into the OSPF domain because it's a directly connected label. So if I do a show IP route to the 7.7.7.7 network, you can notice that it knows it via EIGRP 200. But you can see that the distance is 1,170, which is not regular. But you can see that it was redistributed from 10.1.6.6. Can we take a pause, or is somebody lost where we are still?
So it's still a bit confusing, but I know we'll get it. We'll go forward, like with more examples. Yeah.
Okay, let me stop sharing. Let me stop sharing. Okay. Let me stop sharing, and then let me share. Let me share this. So, if you can see my screen, could you let me know?
Yes, these are the topologies back up.
Yes, we
Okay.
can.
Okay. So basically, what is this between routers? Router 7 and router 6 are connected to zero interface, right? They can speak to each other on, so those, both of those, their interfaces are in the OSPF domain. But router 6 also has its interface on the EIGRP domain.
Okay.
So these two can speak, 6 and 7 can speak to themselves only via OSPF because they're OSPF. But then 6 and 1 are actually EIGRP neighbors. They can speak EIGRP. But in the OSPF, they've advertised the loopbacks to each other. But then router 1 cannot know how to get to it because it's in a different routing domain. So that is why router 6 is now redistributing it from its traditional EIGR OSPF domain into EIGRP so that it can be reachable from router 1 that is in the EIGRP network. Is it clear?
Yes, it's clear.
Okay. So let me share. So let me go to router 6 and do a show IP interface pair. If you notice, router 6 only has one interface up and one loop back up, right?
Yes, correct.
Okay. Let me do a show IP EIGRP interfaces. You can see that its gigabit interface and its
9.
loopback interface are
Yes.
in EIGRP.
Yes.
You can see also that advertising its loopback and its gigabit interface into OSPF, right? If I
Yes.
do a show IPsef, so you can see that it has on the IPsef, you can see it knows the route to 10.1.1.2, 10.1.1.1, 10.1.1.6 is already advertised, and 10.1.1.7, which is router 7, right? We can reach those, but it's only routes there. Let's go to router 7. The router 7 can hit. Have a route to router 1. Let us try. Can reach router 1. But then they are not exchanging routing in router 1. So that's what it is. So where were we supposed to go to again? So configure router 6 to redistribute OSPF into EIGRP such that routers 1 and routers 2 go directly to router 7 to reach that network. So we are supposed to play with some filtering, but let's go back to router 1. Let's go to router 1. If you notice, it's saying from the question, it says they want router 2 and router 1 to go there. Let's go to router 2 and check. Okay. If you notice, it says it's coming from gigabit from this interface, but where is it coming from? It's coming from router 6.
6. Yes.
And we said we want it to go straight. If you look at here too, it says it's coming from router 6. Now, this happens because the guy is advertising itself and then is setting up himself as a net hub. So what you are supposed to do in that is, if it configures itself as the next hub, everybody will go through it. So if you look at it, that means router 6 has told them on that gigabit interface 0/9 that he is the next hub. So under that topology, let me exit here. We're in router 6, yes? We're in under the address family. So let's go to the address family interface G0/9, where it is connected, right? And let's do this. Take a look at this command. So by default, it actually tells itself, right, that it's the next hop. So all we just need to do is disable this. We just need to disable that. So once you do that, when it's now, because what you are saying as next observers, let me give an explanation. I, for instance, send a message to this class. And knowing Mubarak for who Mubarak is, Mubarak now wakes up and says, he changes the message and says the message came from him, right? So you don't want to talk to me about it because you thought the message came from him. But no next self means preserve the origin of the message as the message was and just carry it across. So now that we have disabled next self, if we go to router 1 and issue the same command, can you see where it's coming from now? Hello?
Yes, I can see. We can see it has changed. So it's not more redistributing from it's not more redistributing from routers.
It's redistributing, but instead of router 7 was saying, 6 was saying, I'm the one that is sending this message, it is me. And then no, we went and used the command no next hop
No
self.
next hop
Don't
self.
say self, don't say it is you, because it's coming from your interface. We agree it's coming from your interface. Tell us where exactly that route is coming from. So you have this issue in EIGRP a lot, you have this issue in BGP a lot. You see the same thing has happened here.
Okay, so you have to put the no next stop command here also.
Thank you. If not, it will, since he knows the route, to say, I am the one advertising the route, come through me to get there. But then when you say, no, don't make the next, just tell my route, ship my, I know it's coming to an interface, but just tell them that it is me you are learning it from. Don't say it's you. So let's not do rumors. So it's almost like disabling rumor mongering on the routing table.
So I just wanted to ask, if you maybe forgot to do something like this in a production network, what could be the effect?
Okay, so in a production network, let's assume over this connection, right?
Yeah.
I want to do some sort of security pairing on to do BGP or something. Or my firewall team now decides that, oh, this is coming from a branch, right? And this branch IP is that .17, right?
Yes.
Whitelist only .17. And .16 is saying I am the person pushing the traffic. What would happen?
The firewall will drop it because the source is different.
Thank you. So there are some types of commands or configurations you do in your specific networks that you have to be source specific. Okay, so this is 1.5 hours of eating book. We have a little to go. Should we pause?
We can continue. It's quite fine. For me, I don't know about the rest.
Okay.
Let's continue.
Okay. Okay, we are an hour and a half in, so it's fine, we'll continue.
So what we've done now, does he answer that to show that R1 and R2 go directly to R7 to reach the 7.0 network? Does that cover it? With the no nest up command that we did on router 6, does that cover that? Or we Islands, did you get me?
Hello. So
Okay.
what next are we supposed to do?
So that means now we've closed out the number 6 option where R6 is supposed to distribute OSPF into IGRP.
And then
So
he said R1 and R2 should go directly,
to
R7.
R7.
That's why we needed to see that hop as itself.
Okay.
Right?
Right.
So now we've done that. Now the next thing is they said all routers in the S200, their hello timer should be twice the default. Okay? So how do we even know what the hello timers are in the first place? But we know that routers 1 and routers 2, and I think router 3 has OSPF 200, right? EIGRP 200, right?
Yeah,
But let's
yes,
confirm. Show IP protocols.
There's a space in between.
Yeah. We have EIGRP 200, don't we? But then how do you even know what the timers are? Can we see it from here?
Active timer 3 minutes.
Active timer 3 minutes.
But that active
timer
timer means it's active. That means it is running, it's counting down. If you do that again, if we do that command again, you see that that active timer will have dropped again because it's dynamic. It's 3 minutes for that. But then we're actually saying that we should configure what and what. Now we should configure the hello interval.
Hello interval.
Thank you. So if you do a show IP EIGRP 200, and then remember that the timers are on the interface, right? The interface, detail, and then include interval. So what's it telling you now?
Hello interval is 5. Hold time is 15 seconds.
Okay. But then you do not actually modify the whole timer. It's the
Hello interval.
Thank you. And then it is actually configured on the interface. So if we do a show run now, if we show run 5 section EIGRP, let's even know what we have under EIGRP 200. And remember, it's not under the EIGRP process the timers run. The timers are actually on the interfaces that connect. So that configuration is actually an interface sub configuration.
Okay,
So let's go and look for Salem.
Not the router configuration.
No, not the router configuration. Remember, you still have to go to that address family, IPv4.
V4.
Autonomous system for this one is what? 200, right?
Yes.
And remember, we have to go to the interface gig 0/9. Yes. And then they said the hello interval should be what?
Twice the
number one.
The default, so that will be 10. We'll be going from 5 to 10.
Okay. So we'll now say
hello interval
10. So which was the last command we used? Has it changed?
Yes, it has. Yes, it has changed. The yellow interval has gone to 10 now.
As against what was it before?
5.
5. I'm trying to find it and highlight it.
I'm pretty sure if we don't change it on the other side, so there's going to be an issue.
No, now that is the funny thing. Timers for OSPF and maybe EIGR. The configure timer for EIGRP's hello actually tells the neighbor that, come, this is who I am. So the timer you set for EIGRP, you are telling the neighbor what to do. That listen to me. If you listen and do not hear from me from the hold down time around and that it is 30 seconds, shut me down. It is not used for negotiation. Okay?
Okay.
So, show run section EIGRP. So, what EIGRP 200 here is still Salem, yeah?
Yes.
Address family, IPv4, 200, yes?
Autonomous, yes.
AF interface G 0/9. Hello interval.
Interval 10.
And we need to go to router 6 again, right?
Yeah. Is it router 6 or router 3? That's 200.
Router 6. I don't think router 3 has 2. Right? I know router 6. No, I think 3 doesn't have it. It's router 6.
Okay.
It's router 6.
Yeah, router 6, yes, is the one that distributes.
Mm. And then, you know, name EIGRP is low significant, right? You can use one name here, use the other name on the other side, and it doesn't make a difference.
It's the AS number that matters.
So yes, this is the IGRP 200 here. Can you see it? And the IGRP 200 is to Mubarak. Where's Mubarak?
I came late, that's why.
That's why they named something after you. So why should we bother ourselves when we can just copy this? Is it not what we need to do?
Yes, actually.
Eh?
During the interface, hello interval, and
Okay. So let's confirm show IP EIGRP 200 interface detail 5 to include interval.
there's a spelling error.
No spelling error. Once you are piping, if you do not complete some of the commands, it will not give you, it will not give you, it will not give it to you. No, you are piping, so it's like a grep.
Yes,
Can you
like a
see?
grep, yeah. Yes.
Why is he giving me 2? Hello interval is 5. Hold that. Is that? Don't worry, it's fine. So why is he giving me 2 of that?
Including interval, EIGRP, but it's just EIGRP now. Is it because we have OSPF configured on that port also?
Nope.
Because it was configured on an interface.
Are you sure?
Probably has another is running in the default time, I guess.
Probably another interface is giving us that.
Okay, but did you notice that the hello interval changed? The whole down timer did not change?
No,
Yes.
it did not.
Okay. Okay. Any reason why?
Maybe because an EIGRP or something.
Need to be careful because it's actually running through protocols and then it's trying to protect itself so that it doesn't misbehave. Don't worry, we'll come back to that. So, what is question number 8? We're almost 2 hours in.
Configure R4 such that in the worst case scenario, it uses 10% of the bandwidth for its EIGRP updates. This policy should apply to the existing and future interfaces.
Okay. So why would somebody want to do that?
So that EIG updates will not take up the entire bandwidth where it will not even be able to send traffic.
Beautiful. And then back then, with slower links when we were using serial connections, not now that people are using Metro, Ethernet, and fiber to branches, people back then were using 64 kbps for a branch. So imagine if IGRP now decides to use as much as he wants to do all of that. You actually will make it not work. So we are supposed to do that on which of those devices? Router
4.
4,
Router
yes?
4. Yes.
Okay. So remember that in router 4 too, we use name mode, right?
Yes. Sure. Jumping.
So this is what we have here, right?
Yes. IPv4 unicast.
Okay. Let's just copy this and place this. Let's get there. Let's go to the AF interface. But then remember, we are looking at the address. Do you know what AF is? Address family. So, because we are doing address, this address family is IPv4 unicast, yes?
Yes.
So now we can pick the address or we can do the default. Remember the question says this should apply to existing and future interfaces, yes?
Yes.
So to the default, which is all of the interfaces, that is where we are supposed to apply it, yes? That's every interface under that address family, right?
Okay.
We now tell you that the bandwidth is, if this command was, let's do it only on this particular interface routing now, we will just enter that interface and do it. If you say do it on another interface, you can do that, but they are saying on all interface under this address family, future, now and in the future. So we have to go under that address family and specify that in this particular address family. So let's assume real life scenario, you're a network engineer for a bank. You have EIGRP running in your network, but then you have up-country branches, and then you know that because they are up-country, you don't have Metro Ethernet, and then you want to safeguard part of that their traffic that it shouldn't be used for routing. So you can default all those interfaces coming from up-country so that it cannot use more than 10% of bandwidth, right? So by the time you do the bandwidth, it's now telling you maximum bandwidth, right? Are we there?
Yes, we are, Lance.
Yeah.
So 10%. And then if I do a show IP-EIGRP interfaces detail, pipe
There's a typo there.
include bandwidth.
The typo, sir. EIGRP.
Thank you. I think I'm getting tired.
Sorry.
Can you see? So that's about that for that. So yes, any questions for me?
So this particular 10% bandwidth
Yes.
is control traffic for EIGRP.
For control traffic, for update traffic for EIGRP, yes. So for control plane traffic, not data plane. Do you understand? It is not saying so are we there? Hello? Hello, can anybody hear me?
Yes, we can.
Yeah,
Yeah, we can hear you, Lance.
Okay, so we need to understand that we have control plane, we have management plane, we have data plane, right?
Mhm.
So now you know that this routing protocol is routing IP for us. And we are saying now, route the IP for us. That is our data. That's our data plane. But on that control plane where EIGRP is running, do not use more than 10% for yourself. Does that make any sense?
Yes, it does,
Yeah.
Lance.
So yes, we understand that you need to do your exchanges. We need to understand you need to do your updates, but please, our data matters so much to us. Do not use maximum you can use is 10%. And then the same way, you can do storm control to limit broadcast or multicast on switch interfaces with the command storm control, suppress if it gets to a particular level. Has anybody seen that before?
No, I haven't.
Okay, so let's do
So,
a show IP. This is a switch. I mean, a switch.
yes. No layer 3 done on the switch, just layer 2.
Eh?
I said there's no layer 3 done on the switch, just layer 2 connections.
Yeah, cover. Yeah, it's layer 2. What this guy do it? The command is storm control. Interface Ethernet/3.
Okay.
The command is storm control. Oh, this can do storm control, sorry. This can do storm control. Can do storm control. Okay. Can I call it a day now? Or you people still want to kill me?
So I
Hello.
just wanted to ask. So now, unless
Yes.
you specify the bandwidth usage on any other interface in router 4, right? They will all use
Yes.
the 10% because that's not the new default that we've set.
Yes, no, only for EIGRP updates.
Only for EIGRP, yes, sorry. Yeah, only for EIGRP.
Yes, only for EIGRP updates. Are we good on that?
Yes, I am.
Yeah.
Okay. Oh boy. So where did we stop? 8? Let me see if we can do 3 more. Yes, sir. I'm with you, sir. Sit you. Please come ahead, sir.
Sansi, how you tell you say na me?
Here. The spirit whispered. The champion has come.
Okay, my name is showing. Oh, I'm sorry. I thought my name wasn't showing. Okay, just to let you guys know I'm still here.
Oshidi Opa.
You don't enjoy late now.
Okay, let me start on now. I did since I just did quiet. I did since.
You start and go gym, come back.
Then they go do leg work. You don't like to do leg works on Saturdays.
But when I leave that gym first, I pass my CCI. When I leave that gym with. Okay, guys, just continue. That's what I don't finish.
Okay. No, not really. We just have a couple of things to do. Maybe let me just play with some summarizations for them.
Okay.
Let me just play with summarizations for them. So who can see what I placed on this? Oh boy, my back is paining.
But you're not adding. That's why you're not adding any. You're not adding any VRF, have you?
No, not yet. Overkill, not yet.
Okay.
Overkill.
But if it's CCNP, this is CCNP standard now.
Yes, it is.
Come on now, then they should touch VRF. They can't escape it.
Okay. Don't worry.
They should touch VRF. Maybe just introduce VRF between just two routers. Just nothing complex, just between two nodes. That's all.
Okay. Not a challenge. You guys heard what the CTO said. So let's see if we can run through this and then let's play. So what do we have next to do, people of God? Hello?
Sorry, I was speaking, I was on mute. Configure R1 to summarize its loopback interfaces and advertise a single summary in the EIGRP AS100 routing domain.
Okay. So it's look back. So let's show IP interface brief. Let's include look back. So this is the look back. There's a challenge for EIGRP, right? You cannot under the F interface mode. You do not have. Let's do this. These are the interfaces we have. So let's do this. Oh boy. So does anybody know how to make this typing error not work and go away?
Yes, you do know DNS lookup.
Okay. But has anybody actually ever wondered why this thing does what it does? So by default, anytime you type something, your machine, the router actually tries to telnet into that device. That's why it's not resolving it. So you can do this. Or you can go to, please watch this line console 0, no transport, preferred. So I can do this now. And it will not clear. Have you seen that trick before?
Yes, I have.
CCI level trick.
Sorry. Okay. So the problem is to summarize. Let's do this. Show run 5 section EIGRP. So it's supposed to advertise it and summarize it in the AS100 domain, yes? But the
That's very
problem
much correct. Yes.
so that'll be AS100, yeah?
Yes, 100.
That'll be Malik, yeah? That'll be Malik. So this will be the same address family. But there's a problem. Under the AF interface default, right? There's no summarization option for you to be able to summarize it. So the only way you can do that is you actually will have to go under the interface, right? And then summarize under the interface. So let's do a Stripe interface brief again, and let's see. So the question says, it's interface that is actually in the, we're looking for its interface that is in AS100. So if you do a show EIGRP interfaces, these are the ones under AS100 under Malik, and they are G0/2, G/3, and all of that. So we need to go under that interface and then summarize all these loopback addresses as one particular summary address. So if we go under AF interface for G0/2, we can now summarize the address to 1.1.0.0. Do you guys remember how to do summary addresses? Hello?
Yes, I do.
Okay. So just go under all those interfaces and summarize the address, and then just go to the other guys and verify if we actually did summarize the address. You can see that there was a graceful restart. So we show IP route, EIGRP, pipe 2, and begin with the gateway. Can you notice that this has been summarized totally? Hello?
Yes.
Yes, sir.
We summarized to /22. Let's see if we can find where we did a show IP route earlier on. You can see that all these routes were 3 different routes, right?
Yes.
But right now it has summarized all those routes to one. Question is, why do you want to summarize that? Okay, can you see this route? Do anybody know why this route is showing a D and an EX?
External. Yes.
External. That's the route we
router 7, which router 7. That is
that we
redistributed via routers. Yes, via router 6. Yes.
Okay. So I think we are done with 9. We are done with 9. Well, let's go and check. Let's go and check. Yeah, you can see it has all been summarized. So what do we need to do with 10 now? Configure router 1 to limit the number of prefixes. Beautiful. Okay. Does anybody know a use case scenario why we need to limit the prefixes a router will receive? Anybody want to try? Hello? Anybody want to try? Hello? I'm still on this call.
We are with you.
Okay. So sometimes you want to limit it. You just want to limit it because one, you want to summarize. Two, you don't just want overload on your processing power, and they don't want to fill up your routing table. So you can actually, and it's easy. And what it says is, okay, this one says should give you a warning, right? So just under the same. So I said if it's a maximum of 50% on AS 100, yes? So I think this is it. So we just tell it that this particular neighbor the maximum parts it should receive. Number of the minimum is 10, and then it should give when it gets to 50%, give us a warning only. And that's about what you need there. But let's go to router 5 and be sure. Hello, can anybody hear me?
Yes, Lance, we do.
Okay. So let's do a show interface, show IP interface brief. Just type an X to exclude unassigned. How many loopbacks do we have on this guy? So since you say maximum of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's see if we can look for its trouble, and let's see if we can trigger the warning. Let's see if that configuration is correct. Network. Sorry, I forgot this as usual. 51. Three. As of 54. Let's go back to router 1 and see. Can you see this? Can you see the warning?
Yes.
Can you see the warning?
Threshold, yes. Threshold prefix level 5 reached.
Thank you. Because we actually made it that if made it 10 and then we said 50%. If you had made it 12, right? If you had made it 12, let's make it 12. So let's make it 12, and then let's see what will happen if we add another one. If we add 55, we shouldn't get a warning. By the time we add 55, telling us prefix level has been reached. Oh boy. So, thank you guys for hanging out with me this morning. Can I have any questions? I think we are done for today. Till this time next month.
I just wanted to ask the previous
Yeah.
recording and this one, where will they be put? Like for other.
Ask Aquaman. If Aquaman has come back from the sea, he should be able to. He will drop it up on the chat. Okay.
Nah, that will be my.
Anybody want to ask?
That will be my.
Yes.
Right. My is Aquaman.
Yes. Yes. He's Aquaman. He plays with Aquaman when he goes under the sea. Okay. Anybody want to ask me any question? I need to go do coffee.
No question from my last. Thank you very much.
Okay, guys. Thanks for hanging out with me.
A question, Mr. Land.
Okay, shoot.
Okay, so this you configured arrow 1 to limit the number of received prefix from arrow 5 to 10. What use case is this applied, please?
Okay, let's assume you have some kind of network where somebody is connecting to you directly, and then you're actually doing some kind of extended hub and spoke, and the person just keeps flooding you, and then you actually basically just need a summary route to that place that is a stop. So you can actually just trigger that so that it doesn't slow down your system. But this is old technology things. It was just that it was possible to be done, to be able to shut down the link if it wants to worry with too much updates. Back then, routers didn't have this much power, this much processing power. So we had too many things we needed to limit.
Okay.
Any more questions, people of God? I need to run. I need to drink coffee. Now, have a nice time, guys, and bye.
Thank you, Nas. Have a great day.